Okay, good morning, everybody. This afternoon, we're going to go on a slightly different track to what you might normally expect at EPFL. We're going to bring sustainability into the lecture. And you may wonder why this is. But during COVID, I followed a couple of courses at the University of Cambridge on business sustainability management and the circular economy. And as part of this course that I followed, you had to come up with an initiative, and you're going to have to come up with your own initiatives today as part of your group projects, okay? And my initiative was to give a course. This is what I'm doing now. And one of the things that they said is there was a collaboration between universities in New York and universities in London. And they said the best way to teach sustainability was to embed it into lectures rather than give a separate course on the topic. So what we're going to do today is to look at sustainability as the problem and a little bit look at climate change. We're going to look at some of the social issues. We're going to look at the transition that we need to make to net zero. So we're coming from a problem towards how to address the problem, okay? We're then going to look at the linear and the circular economy, a new economic model, which will leading to how can we enable sustainability in the future in your careers? And one of the ways of doing this is via initiatives, ideas, things you can do. And the message is climate change is a huge problem and no one person can address it, but every person can have an initiative to do something in their sphere of influence. And your sphere of influence will change in your career and it might get quite big. But let's start today. That's what we're going to do. It's going to be a journey. So this will be a first lecture, and then I'm going to present towards sustainable composites. Where are composites looking in this kind of mirror? And then at the end, we'll look at some initiatives. Okay. So first thing to say is now is the best time to be an innovator for the future. It's really important because we need to change so many things. We need scientists, engineers to innovate. So I want to motivate you to go from thinking in a linear fashion, as we've done so for the last 70 years, to think in a more circular fashion. I want you to understand climate change effects and what net zero is. Now, are any of you following the sustainability minor? Yeah. Okay, so you can come up here and help me give the lecture. No, I'm serious because some of you may know more than I do about some of these things, okay? It's a huge topic and we learn together. What the role of composites can be in this, it does have a big role to play. And I want you to understand the difference between the linear and the circular economic model. And lastly, to think of your own initiatives in your group projects, okay? Pretend you're in your company, the person responsible for sustainability in your group or people need to think of initiatives, things you can do. So there's a lot of negativity around climate change, but what's your positive vision for 2050 for a net zero scenario? How could we improve things in the future? Well, we might be generating a lot of power from photovoltaics and wind energy versus burning coal and gas today. We might be sitting in a hydrogen-powered aircraft. Might be seeing lots of composite pressure vessels to contain the hydrogen. Electric vehicles getting up to 1,000-kilometer range. We want the world to be a place where we can enjoy being outdoors, rewilding of nature, and some equality between the global north and the global south. So try and think of a positive future, not just the negative possibilities that there are. So this is my definition of sustainability. It's avoiding the depletion of our natural resources in order to maintain a balanced ecosystem and preserve natural capital while meeting our needs, but without compromising the ability of future generations to meet their own needs. Okay, and what we're going to discover today is that that definition is a definition, but it's so much bigger. There's so many things you can bolt onto this to make it really, make any sense at all. So sustainability is not staying the same. That's one thing to say. So we're going to look, first of all, at the problem, climate change, and where it's come from. We need to do that in order to look at how to address it. How many of you have heard of the Holocene? Any geologists in the room? Well, it's a geological epoch, which is the last 10,000 years of Earth's history, where the Earth temperature has been flat, okay, straight line. This is data from the Greenland ice sheet, and you can see as a proxy, but it's been the last 10,000 years is what's defined this geological epoch. And you can look at Earth from space and see how beautiful it is, okay? It's an amazing planet. As we all know, in the last 100 years, since the Industrial Revolution, it started to increase. So it's been stable 10,000 years. And in the course of this time period, we've managed to heat up the planet by 1.1 degrees centigrade. And you've all seen these kind of YouTube videos of icebergs carving off in Greenland and fires and the last hot summer. You know this is real, okay? I hope you will believe this is really real. The science is very strong. Where's it come from? Well, first thing to say is this is not new. Okay, how many of you have heard of Arrhenius, or you material scientists? He didn't just develop this equation. He also published in 1896 a journal paper correlating CO2 to the Earth's surface temperature. Okay, this is not new. Okay, some people have their heads in the sand about it, but this guy was quite before his time. So what's given rise to this increase in temperature? How many of you have heard of the Great Acceleration? Okay, hope they teach this in their sustainability course, but this is what's happened really since 1950. Okay, it's the Great Acceleration. You see these huge growth curves, and you can look at this in two ways. One is socio-economic trends, and there are 12 of these that you can look at online if you want to. And what you can see is that the population of the world has really increased. The gross domestic product has gone up. We're using more water, but it's not just increasing slowly, it's going at humongous rates, okay? It's really huge. Primary energy use, really going high. And almost every generation, you know, my parents used a lot, I used more, and my kids are using even more, okay? It's not really going the right way. The number of new vehicles on the roads, fertilizer consumption. So those are the socio-economic trends. And I'm not saying if they're good or bad, but they are real trends. This is real data. You can then look at the Earth system trends and what are these doing to the planet? You can see that CO2 is going up, so is methane, so is temperature. Ozone we've managed to cap with the Kyoto Protocol. So that's a success story. The oceans are getting more acidic, and this takes a long time to reverse, tens of thousands of years. And the biosphere is being degraded. So those are some of the trends. Well, then you can say, what about research? And if you take US patents as a proxy for research, I couldn't find anything on papers. So the number of patents is going up in a similar speed. Innovation is going up at a huge rate. So what I want to say to you is we need to find a way of advancing, but to do this in a more sustainable fashion without taking a mortgage on our children's futures, okay? So we need to find a way of maintaining growth, advancing. And the thing is, if you think your mind's just back to COVID, there was a survey of professors and students, and 30% of students had mental health problems, okay? 40% of students, 30% of professors. So trying to maintain this growth curve is actually frying our own brains. I myself have had a burnout in the past, so I know what this is about. So we need to find a way to continue advancing, but looking after ourselves at the same time, okay? We're really important. So where does all this CO2 come from? This is a graph from our world climate data, which shows you where CO2 comes from. And what you can see are chemicals here and here. So this is the kind of plastics industry. You can see road transport, 12%, aviation, and also some other materials, iron and steel and cement. So your mechanical engineers, your material scientists, this is our toolbox that we play with, okay? So what we do and what we touch, it's adding value to the world by building things, but it's emitting CO2. So how can we make these two things in the future go in parallel in a better way? So I'm going to introduce you to several key concepts in sustainability. And have either of you two who have done the sustainability minor heard of the planetary boundary model? No? Okay. I was going to ask you to present it. So, okay, this is a model by Stefan from the Stockholm Resilience Institute, and his group has divided the planet system to have different boundaries. So what you have is here, green, it's safe. In kind of yellow color, it's getting dangerous, and in orange, it's a big problem. So climate change, we're at 1.1, we're trying to keep below 1.5, it's becoming a problem. There are several which are not yet quantified, one of which is novel entities, and actually that's us, material scientists inventing new materials. I'll come back to this. Ozone, that one's relatively okay. Aerosol loading, not yet quantified. The oceans are getting more acidic and it's approaching the safe limit. Nitrogen and phosphorus flows come from agriculture and animal manure runoff. That's way out of control, okay? Really causing problems. Freshwater use, kind of okay, but getting near the limit. Land system change, a big issue. This is a documentary about it on Netflix, and it's really, really good. And I recommend you to get some friends around, grab some beers and watch it. What's important for us today is this novel entity is one. So as material scientists, we invent new chemicals. So back in the 50s, there was a chemical invented called perfluorooctanic acid by 3M, which DuPont used as a processing aid in making Teflon. Anyone heard of this? Yeah, okay. So it's in your blood. It just doesn't go away. And the thing is, that was invented with good cause to make non-stick frying pans and clothes that didn't stain. If you've seen the film, you know all about it. The thing is, for a chemical to pose a threat to Earth systems, as is defined today, it's got to have a disruptive effect on a vital Earth system. This effect isn't discovered till it's a problem at the global scale. Whoops, a bit too late. You want to find out a bit more quickly than that. And the effect is not readily reversible. So my generation, Generation X, invented all these amazing chemicals, but some of them have really big problems on the environment. So always think about this when you're developing new materials. Okay. Another concept in sustainability is Earth Overshoot Day. And this is basically, you can look at the world biocapacity and the world's ecological footprint, and you can work out when you've used up your year's credit. So your parents giving an allowance for the month and you spent it on the 12th. This is what this means in real terms. So this is what it means. You've used up what the world can regenerate partway through the year. And here's Switzerland. Switzerland has used up its fair share of resources by May. So we're using up more from the Earth than it can easily replenish from this great acceleration. Another concept in sustainability is the shifting baseline syndrome. And you can see here, if you were in the 1800s and you went snorkeling in the ocean, you'd see all this fish and you think that was normal, okay? You go swimming in the ocean today and you think it's normal, but you're not really, you know that should maybe be a little bit more there. But if someone from the 1800s was to go teleported, as in the Adam Project, anyone seen the film, the Adam Project? Yeah. So you go back, they'd be horrified. Okay, what's going on? And it's because what we consider to be a healthy environment now, past generations will consider to be degraded. And what we judge to be degraded now, the next generation will consider normal. That's quite scary. And our memories are quite short. So when I first came to Switzerland 25 years ago, I'd go to the Col de Montgeroux, and the snow was 2 meters high on each side of the road. Now it's down here. For me, that's not normal, but for you, it is. Okay? So you really need to look at things with past eyes as well as today's eyes. So we need to have this memory, knowledge, and experience of past environmental conditions to understand the damage that we're doing now and how much our environment's changed. Another example here, the Jungfrau, this is the Große Hallig Glacier. That's where it was in 2018. The guys in ETH Zurich have predicted this to the end of the century, and it goes down and down and down if we carry on as we are. Okay, it's quite shocking, but they will think this is normal when they're skiing, ski mountaineering up here. They'll think it's normal, but it's not. Okay, and it's changing in our lifetimes really quickly. So we talked about the Holocene, which was the stable geological epoch for the last 10,000 years. There's now a new geological epoch that's being proposed called the Anthropocene. Okay, so it's what we have done as human beings. It's the commencement of significant human impact on the Earth's geology itself. And this is still being ratified, but basically they're proposing, most likely, it starts with the introduction of the atomic age, because in the 1950s, they conducted all these atmospheric nuclear tests, and that is now present in the geology of the Earth, okay? And it's caused, this might shock you, 2.4 million deaths as a result of that atmospheric testing, okay? People don't talk about this. We've also terraformed the Earth. Terraforming wasn't invented in Minecraft, okay? So my kids play Minecraft. We've done it to our planet, that's a diamond mine, and to give you the scale, these are apartment buildings, okay? We have terraformed the Earth, hacking away, looking for diamonds. We've also done great things. We stood on the moon, we've seen Earth from space, and we've invented surgery. So that's what the Anthropocene is. In this last 50 years, this great acceleration, we are really changing the planet. So global warming thus far is we're somewhere up here, up this growth curve. And we've warmed the Earth at an unprecedented rate since the mid-20th century after this very, very stable period. Okay, so there are different climate change scenarios. So that's the problem. And now we have to look at what we can do. And what can we do as composite material engineers? Well, this starts off looking at these scenarios, okay? As in any modeling scenario, you have high, medium, and low, okay? The very low emissions target meets the Paris Agreement targets, trying to limit warming to 1.5 degrees C. Then there's a low, mid, high, and very high. At the moment, we're on this orange curve, this mid-level emissions curve. COP27 is coming up in a couple of weeks. I encourage you to listen to the debate. And we need to get to what's called net zero. And we're going to look at that later on, which is this trying to keep this 1.5 degrees C target. Because if we don't, it's really a problem. 3 degrees of warming really is an issue, okay? We don't want this to happen, but it's getting into the mainstream press, the kind of things that everybody reads, not just climate scientists, okay? People are talking about it. COP26, this is another climate action tracker webpage, and what they're doing is they're looking at the difference between policies and actions versus what's actually a target and what's pledged, okay? So this is a current policy. We're actually heading for 2.7 degrees global warming. So we need to have more action behind the pledges, okay? If people actually did what they said they would, it would be better, but it's still not enough. The window is getting smaller, but it's still possible. So there's this ambition gap between what we say we'd like to do and what people are really doing. And that's what this lecture is about. It's trying to envisage you in the future to help do something about it. Okay. So what about Switzerland? Okay, we are all in Switzerland. Switzerland is a net importer of CO2. It's a high-tech country. And this is a little web page where you can look at CO2 emissions embedded in trade. And you see a rather dark red area for Switzerland. Okay, why is that? Well, this is CO2 production. So our production-based CO2 has been nicely dropping. We're not emitting so much CO2 in the country, but we're buying stuff which is made in China, and that's So the CO2 is being emitted somewhere else. Okay, so that's really a really important thing to realise. There are big emitters of CO2 in Switzerland, the concrete industry and the pharmaceutical industry. They're the two biggest. Okay, someone has to be. But what we need to watch is our consumption-based CO2. We can't just say we're doing well. And the thing is, if we stay on this 2.7 degrees C track, Switzerland is actually set to warm up more than the rest of that's a mean, okay? Some places will get hotter, and Switzerland is actually one of them. And if you look at the median case from the Météo Suisse, from the Swiss government, they're predicting 2060 a +4 degrees C rise in Switzerland, okay? Or when my kids are retiring and they're in their apartment blocks in Lausanne, it's going to be absolutely sweltering. We need to do something about this, okay? So Switzerland is going to suffer. It's going to get tropical and hot and humid. So that's the climate problem. And we're going to look at 3 Ps today, okay? We're going to look at the planet, just talked about that. We're going to look at people, and we're going to look at profits, okay? The role of business. So now looking more at the role of people, another model in sustainability, you must have heard of this one, okay? 30 seconds, can you tell us? So this is by Kate Ratworth, an economist in Oxford University, really good summary. It's basically saying we don't just have planetary boundaries, we also have these social shortfalls. So we need to look after the planet, but at the same time that the planet's suffering, the social foundation is suffering, okay, in these different categories here. And we need to work on the green space, which is a kind of a more of a just space between the two. All right, so people are a big issue in this, not just the planet. And it should be our goal. So very interesting. You can watch a talk on that online. And some shocking statistics: dollar millionaires make up 0.7% of the adult population, but hold 50% of the global wealth. The richest 1% own half the world's wealth. Now you might say, I'm not the richest 1%. But what you don't realize is when you leave here and you get a job at DuPont or in Vista or UBS, you are on a Swiss salary. Okay, you'll be one of the world's richest 1%. Okay, so this is us. There's a garage near where I live that sells these cars. This is not my son, but he likes to go and look at these cars. Okay, I don't have one of those, but these are the numbers, and it gets worse. The world's 26 richest people. So imagine that you are these 26 people, you own as much as the 50% poorest in the whole of the earth. Doesn't really seem fair, does it? Doesn't seem just. That's for you to decide, of course, but it's part of this donut model problem. The money is not shed around enough. Now you can start to correlate carbon emissions to wealth. So the richest 1% have used 2 times as much carbon as the poorest 50% of the population over the last 25 years. So here's the richest 1%, and then the poorest 50%. Okay, and you can look at where that goes. It's in air travel, land travel, housing, manufactured products. It's not in food and services and clothing. It's how we live and travel. So this us 1% need to look at what we do with new eyes, I believe. So what Ban Ki-moon is the former chair of the elders at the UN. He's basically says that our current, I put in parentheses here, neoliberal economic model has been an enabler of catastrophic climate change, but equally catastrophic inequality. And this is something that we need to address: disproportionate carbon emission from the wealthiest in society. So then, to try and address this, Who's heard of the Sustainable Development Goals? Okay, more people. Anybody else want to say what they are for 15, 20 seconds? Okay, so the UN has these goals, and there are 17 of them. Some of them you could argue slightly contradict. It's a very complicated interaction because we're trying to have climate action and no poverty, and we're also trying to have sustainable communities. But all in all, they're trying to go in a good direction. And composites contribute to many of these. Okay? So wind power, hydrogen storage, innovation for industry, so climate action, electric vehicles, or all these things you can start to say are maybe helping to address these, particularly these sustainable development goals. And often when people have an initiative, they have to attribute it to which SDG it addresses, okay? Kind of common language. So I would encourage you to do that. The one where composites have a problem is goal 12, which is sustainable consumption and production patterns. So a lot of the things that composites are being used for are not sustainable, okay? And an enabler to this is the circular economy that we're going to dive into in a lot more detail fairly soon, okay? So what I'd like you to do is to point your, I hope this works, point your phone at this QR code and type in a couple of words, your own personal definition of sustainability. Try it myself, see if it works.
Apparently it says that the event is not
Then you have to scan the QR code with your phone. Then you go to polls. Is it working for you now? Yeah. So it's key for the future, it's needed, it's complicated and challenging. Some recycling, focus on development, focus on resources. It's our responsibility. It's essential. It's about mobility and community. So you've got people aspect there inside. Really good. It's a priority. Looking at our needs today without compromising on the future generations. Okay. One last person's typing. So this is being recorded on Zoom, so you can see it afterwards. So I think the big message is that it's essential. It works out the most common theme by itself. Okay, so we've talked about the issue of the planet being out of balance and the planetary boundaries being out of balance. We've looked at wealth inequality and some of, very briefly, the Sustainable Development Goals. You could spend a whole day looking at those, and I encourage you to. I want to look at this, what we call the net zero transition next. And as we said, we want to look at this reduction scenario where we get to negative or zero emissions by 2050, which is what people like to call net zero. And this needs a huge change in emissions. Okay, so how are we going to do this? How do we suddenly change these curves that are growing like this to make them turn and then start to come down? Are we going to have a plateau before they turn? No one knows, okay? So these are projections. What we're looking at is the sum of human-caused greenhouse gas emissions and what we can remove from the atmosphere. This has to become balanced by 2050. And that means we have to significantly reduce what we emit from agriculture and transport and industry and heating. And we have to try and sequester some. Big challenge really is to reduce what we emit because anthropogenic carbon removals are very difficult. Okay, so that's what people are calling net zero. So to limit global warming to 1.5, we've got to try and reach net zero no later than 2050. So that is the challenge for your careers. Okay, all the companies that you work for will be looking at this. Companies are looking at it now. That is the good news. Not everybody is, but a lot of big companies are really focused on this. It will be the focus of research as well. Okay, so we need to, this is our big theme. Going towards net zero 2050, the IEA have published a roadmap of how they think we should get to 2050. Many organizations have, they're not all the same, okay? They have similar ideas. First thing is to say GDP is going to carry on rising, and so is the world's population. That's not helping to reduce emissions, but it's a fact. It's going to happen. So don't forget that. Looking at how we use energy, you can see we're about here. This is the COVID dip. From here on, it's a prediction, and it's already wrong. That's a report from 21. It's actually already going back up above where it was in 2020. But somehow we need to reduce the energy we use and transition from oil and coal towards renewables. And the renewables use lots of composites, okay, which is good news, wind energy. But we need to change how we do wind energy to recycle the materials, and we'll look at that in a bit. So you can see here, wind and solar are really going to grow. There's going to be a huge demand for these materials and a huge recycling challenge for these materials. Here you can see how different sectors are going to have to change how much CO2 they emit. So power generation has to have a massive drop, as does transport and industry. So composites are involved in transport, they're involved in aerospace, they're involved in automotive. Okay, so a big opportunity for us to make a difference. What are some of the kind of milestones towards 2050? This is again from this net zero report. We're not going to go through all these. I'm just going to highlight some of them for you. By 2030, there is 1 terawatt per year annual solar and wind addition. Okay, that's already been planned. The automakers have already planned and are changing and investing to make 54 million battery electric vehicles, okay, by 2030, greater than 50% of total vehicle production. So they're investing $1.2 trillion in this. So redesigning how cars are made completely from diesel, gasoline to electric. It's a huge change for mining, for materials, for rare earths, to supply chains, okay? Enormous change in the industry. By 2035, there'll be the world's first zero-emission aircraft, probably running off hydrogen. And the EU should be at net zero with its electricity generation. Seeing is believing, but it's what the EU are stating. By 2040, Airbus have said there'll be 39,000 new passenger and freight aircraft, which are composites intensive. So it matters how we use composites, okay? It's going to be still a large growth in transport. By 2050, there'll be twice as many vehicles on the road as there are today. So imagine you're driving down the highway towards Lausanne, twice as many cars. It might be electric, but that's a lot. 86% will be electric, and we'll be at 70% renewable energy, which is really important from PV, from wind, and also solar. Okay, so that's what's likely to happen as the main technological trends going up to 2050, which is what industry will be investing in. Something that's talked about in the sustainability world are stranded assets. So you can imagine that you own a coal-fired power station, and then people are telling you you've got to turn it off. But wait, it's got another 40 years design life. I'm not turning it off yet. I haven't recovered my investment. So your asset becomes stranded. You can't use it to the end of its life. Okay, it's a big issue in the industrial world. You can imagine automotive have these production lines to make car engines. We've got to stop making them, make electric motors. Okay, so your plant becomes a stranded asset. And changing the course of these big industries is like changing the course of a ship. It takes a long time to change direction. Once it does change direction, a lot happens. We need to be patient, but we need to invest in new technologies. This is a study that shows the amount of value of stranded assets by 2050. So it could be 10 to 20 trillion dollars of heavy industry that is stranded, that needs to be retired before the end of its useful life. If we do it soon, it's cheaper than if we delay. So that seems negative as a stranded asset, but on the same time, we can look at where can we invest in the net zero economy, okay? So here you can see trillions of dollars investment compared to today by sector. Where are people going to be spending money? Okay, you can look at by sector. So it's power generation, infrastructure, transport, buildings, and you can look at technology. Huge increases here, again, in how we generate power and also on transportation. So renewables growing here. So we're going to be investing. It means job loss in coal and oil, job growth in renewables and biomass. Okay, so think about that in your careers on where you go. You want to go into an industry that's growing rather than declining. McKinsey have published a study where they say there's 275 trillion of cumulative spending required on physical assets to reach net zero. So a huge opportunity for investments. And this is equivalent to 7.5% of GDP. And I'm not going to go through all of this, but just for reference, global arms spending is 3.7% GDP in the US. So we're talking about spending a lot of money, but the difference is it's value creation and it's smart projects and it's employment. You can also take what we spent on COVID, and if you spend 3 to 4 times per year what we spent on COVID, we'll get that. But rather than being, a panic and a shutdown, we're growing, we're doing exciting things. So we have to start investing. Some good news in the US, there's the Climate Inflation Reduction Act 2022 that's just been passed, and this is 370 billion, where the US government has pledged this to help fight climate change, to get a 40% reduction in US emissions by 2030. So countries are starting to put some money on the table. So what are some enablers to this transition? They're not just technological. Okay, technology is not going to solve this by itself. We need international collaboration. That's easier said than done, as you can see in today's world. It needs to be orderly and just. It can't just be the rich countries doing this. They need to help the poorer countries. We're going to have to change our behavior as a society. That's really true, and that's not easy. People don't like to change. We need to innovate in these new and emerging technologies. Transportation is going to change to electric vehicles. We need to start looking a lot more at biomass feedstock rather than petrochemical feedstock for making materials. And I say biomass, I mean non-food feedstock. We need to change how we generate power. People talk about the hydrogen economy. And a big one here is also agriculture, food, and diet. And we haven't talked about that today, but it's a really big issue as well. Okay. We're going to look more at circular economy, but you could spend, a whole lecture on each of these. But we're going to look at this one. after a break. So if you come back at 5 past on this clock, just take 5-10 minutes, fresh air or drink or bathroom. Okay, so we're going to carry on to look at the difference between a linear and a circular economy. Economics can be defined, this is what Professor Soufani at the Judge Business School and the University of Cambridge, this is how he defined economics in this course. Really simply, as the efficient allocation of scarce resources. So he's Professor of Industrial Economics, he meets with CEOs, boards of companies, governments, simply says efficient and scarce. And he basically said in the course, in front of like 300 people on Zoom, the current economic model has failed because resources are not efficiently allocated. It doesn't mean that the current system is a failure, it means it's not the optimum solution. Because we overproduce, we overconsume, and we overtrade. The system is running too hot. Now, how many of you have old iPads, TVs, screens at home in your house? I know that we do, okay? So we're overproducing, overconsuming, and overtrading. And that's what we need to address. We need to come up with a new economic model, which is an improvement on the current one. And just to touch briefly on food with some shocking statistics. Agriculture uses 70% of global water. It won't help if we try and grow all our feedstock for biofuels. 30% of food waste is lost in the value chain. 46% of fruit and vegetables, still edible mass, is lost. 60 to 75% of packaging is lost after the first cycle. So you go to Migros, you buy your lunch in a plastic container, eat it, and you throw it away. I'm guilty, we're all guilty, okay? But it needs to change. 8 million tons of plastic disappears into the ocean every year, and also Lake Geneva. 90% of the time our cars are idle, they're not doing anything. and transportation contributes 21% to global CO2 emissions. If you go vegan, it's as effective as not driving a car. 90 billion tons of natural resources are extracted each year from the planet. It's a huge amount, doubling by 2050, okay? It's a problem. It's a critical fault sign on the dashboard of your car. You need to stop and go to the garage. This statistic, though, should be encouraging because 72% of economic activity is related to the end user. So if we all decide to stop buying a certain model of phone, a certain brand of PC, those companies will go bankrupt. Okay, it is a fact. Okay, so what we buy really makes a difference. So if we change our buying habits, okay, it will change things. But we are inefficient as a society and we need to improve it. There are lots of inefficiencies which are just lying on the floor, which we could pick up really simply. Yeah? Low-hanging fruit on the floor, don't have to climb the tree to find the hardest to reach apple. There's lots of easy things we can get to. The issue is our linear economy, where we extract, make, use, and dispose. And we assume we have infinite resources. The Earth can give us what we want, and they're free. But it's not true. We have planetary boundaries, and it costs to fix the problem. We also assume that the Earth can regenerate itself from our waste. It's struggling. It's not true. But this is the model that we work off, okay? So in terms of economic terms, these can be seen as a market failure because we're not reflecting the hidden environmental costs in market prices. They do have a cost, but we're not reflecting. We overproduce, we overconsume, and we overtrade, and it's had serious consequences on the environment, so we need to change. So what we try to encourage is the circular economy. Has anyone heard of the circular economy? Do you want to give 15 seconds on the circular economy? Okay, yeah. So we want to rebuild different forms of capital, so financial, manufactured, human, social, and natural, so rebuilding it. And this is a quite famous diagram from the Ellen MacArthur Foundation called the butterfly diagram. What we're trying to do is actually violate some of the laws of thermodynamics, okay, by having loops that don't leak. That's not possible, but we can make them considerably less leaky than they are today. Because today we just drop everything off the end. So we recycle, yes, we refurbish and we remanufacture things. We reuse and redistribute items. We maintain and prolong the life of items, okay? So this is looking at a technical cycle, and you can also look at the biological cycle as well related to agriculture. So we're going to focus on the technical cycle today. So the key elements of a circular economy are it's a change in the way the goods are made and used. So we reuse and we redistribute. It's all these words, remanufacture and refurbish. We recirculate, we maintain and prolong the life. We regenerate, we share, and we recycle. Relocate is not part of the circular economy. We don't relocate our waste somewhere else. So we close loops. We try and design out waste and pollution from the design phase. So if you're designing a product, you need to think in a circular fashion. We try and keep products and materials in use for longer, make them more durable, and we try and regenerate natural systems. So we need to transition from this linear system to a circular model. Again, we reuse, we repurpose, we remanufacture, we recycle, and we regenerate. We try and avoid resource leakage as much as possible. We're making durable products that last, so you have a bottle you can use many times rather than one you use once. You look at leasing rather than buying. Things we buy often we don't use very much, they're idle most of the time. We try and find opportunities where our waste is somebody else's feedstock. So don't throw away your waste, make somebody else buy it from you and give you money, okay? so many companies don't do this, but they can, and there are lovely case studies where they are. It's a journey. It's not going to happen overnight, okay? But we need to shift the system from linear to circular. And again, you kind of try and memorize these words, which is why I keep repeating them to get them in your mind. So as you do your group projects, try and think about having 3 initiatives, what we're going to come to, and think about how you could do this in your projects, okay? Looking at business models, one of the big messages of the University of Cambridge is that business has an enormous role to play, okay, in transition to net zero and becoming circular. So business models should close, material and energy is recovered in the system as much as possible. You try and slow, so we extend the use phase, making it longer. So having a vehicle that lasts for 15 years rather than 7. You intensify, you use the asset more by sharing it. So imagine you live in a block of 5 houses, everyone has their own car. Then you all have a second car. Well, why don't you share it? Okay, that car is then used more, as an example. Dematerialize is a virtual approach to a physical asset. Netflix is a virtual approach to a DVD. Okay? You're not having to make this plastic thing and packaging and take it home. You just watch. We need to be more efficient and more productive. It needs to be financially viable. And we recover and we recycle, we share, we extend the life of the asset, okay? If the machine is turned off, it's not working for you, okay? We need to make sure that our assets are turned on, working for us. One other thing they talked about in this Cambridge course was the circular design guide, really interesting. So it basically says we need to design with circularity in mind because recycling is the tail end of the best case linear economic model. And it's among the least effective circular strategies. It's still important, but we need to do much more than just recycle. And that applies to composites as well. So it's a fundamental change that we need in our production and consumption systems. One example is mud jeans. Anyone heard of mud jeans? They do a lease scheme where you lease your jeans and you can change them, send them back. They reuse the cloth to make new jeans and massively reduce their resource consumption. Okay? New ways of thinking. It's quite interesting. Loss of $100 billion per year in clothing that's not recycled. How can a circular economy tackle climate change? Well, what you've got here is you're saying total current emissions, simplistically, roughly half is energy and half is products. Okay? Half energy, half products. We need to find ways to reduce emissions in our products. So how can we do this? This is a graph which looks at the cost of emissions reductions here, okay, by the amount of emissions we can reduce, and that's the area of the column. If it's negative, it's a cost save. If it's positive, you have to spend money. So by, in dark blue, reusing a product, in mid blue, recirculating it, and in light, eliminating waste, by following a circular approach in cars, sharing, lifetime, remanufacturing, plastics recycling, a lot of these actually save money, not even spending money, okay? It's low-hanging fruit. Some things do cost more, avoiding aluminium downgrading, increasing plastics recycling, lightweighting cars costs money, cement recycling costs money, but all these things, on average, roughly equal out. So that's how the people are saying circular economy can save CO2. To look more specifically at some important materials, okay, industry is responsible for 21% of global emissions, and 60% come from our toolkit as material engineers and mechanical engineers: cement, steel, plastics, and aluminium. So our industries have a huge role to play in how we change. 73% of this is used in vehicles and buildings. You can see here the current scenario. This is the baseline for 2050 and where we want to get to. And you can look at waste elimination, reusing products, and material recirculation design phase and in-use phase to reduce global CO2 emissions. So the materials we use to make things from have a big role to play. Looking at transportation, which is where I spent my career working, it's a huge contribution to emissions in the EU. 60% of transport emissions is from vehicles, twice as many by 2050. We've come a long way from the Model T Ford. Okay, much, much more efficient, and we now can drive around in Teslas, which are electric. The problem is, if you refuel your Tesla from a coal-fired power station, it's actually worse than a petrol car. Okay, data from the EU. You need to use at least a mixed grid or really a renewable grid to get this reduction. Okay, so power generation is important, and we need to increase the amount of renewable energy to recharge our electric vehicles, because at the moment there's not enough charging points and enough power to do that. Looking to the future, people like to talk about the use phase. An electric vehicle doesn't emit CO2 in the use phase. What about how it's made, how it's manufactured? This was shocking to me. The 12 largest automotive manufacturers globally generate more CO2 than the entire European Union. Okay, so how you make the vehicle really makes a difference. Okay, so we have to think about this, and this is kind of how we can start to think. We can make lighter vehicles which use fewer materials, so there's less embodied energy in the materials, and that saves 89 megatons. So looking at electric vehicles, lightweighting, aluminum, composite, make them last longer. That has an even bigger effect. Okay, so make the vehicle more durable. If you look at a vehicle, this part of the vehicle lasts an awful long time. It's the interior that wears out, the seats and soft touch fabrics. But electric motors, they're really durable. They're used in trains. They go millions of kilometers. Okay? So changing how we look at things. An example, Volkswagen is now looking at leasing vehicles 3 cycles. The person who buys the car leases it, and Volkswagen retains ownership and leases it twice more, and then they control the battery at the end of the vehicle life to be reused. They control the lithium. So you might see in the future, you lease your vehicle even when it's secondhand, rather than buying it. Sharing, we've mentioned this. And then in a minute, we'll look at a remanufacturing example, which can also save energy. And that's how they rank up: the current, the baseline 2050 scenario, and then the circular scenario. The biggest one is the longest lifetime, but sharing and lightweighting, it all adds up together to make a difference. And what's important is we don't carry on designing cars the way we always have. This is a study comparing the ESGs, it's the environmental social governance ratings of different car companies. Okay, so Tesla think they're a really green car company because they make electric cars. Well, if you compare their ESG ratings, they are the same. As scientists, you plot this on a graph, standard deviation, it's all the same number, yeah, as an engineer. So Tesla are no better than Mercedes, no better than Toyota. So how they make their car is no better than today. We need to look at how we make the vehicle, not just it being electric. Okay, this again slightly surprised me. Tesla have a problem with their governance rating. That's actually one of their bigger issues due to the particular owner of the company. In the future, people will talk about the 15-minute city where you can get everywhere you need to go with a 15-minute walk or bike ride. We need to use bikes and we need to walk, not just use vehicles. I'm going to skip that because we're running out of time. I'm now going to show you an example of Renault in France and their refactory, where they're one of the leaders in the circular economy. It's embryonic, but it's a bit more than embryonic. They have a remanufacturing operation where they have a reverse logistics system of companies where they collect old parts and they dismantle them, make sure their quality is okay, and then they reuse them and they sell them as genuine parts on vehicles. And they're 40% less expensive than new ones. The volume of parts they've made is quite significant. And you can see since 2012, they've remanufactured 100,000 gearboxes, 73,000 engines, 50,000 turbos, 94,000 injectors. So it's small, but it's not small. It's a start. Okay. And any luck, this video will work.
Le groupe Renault réaffirme son empreinte industrielle en France et crée à Flins la Refactory, la première usine européenne d'économie circulaire dédiée à la mobilité. Précurseur dans le domaine de l'économie circulaire et de la mobilité durable, nous changeons de dimension en accélérant notre engagement pour la préservation du climat et des ressources. Grâce à la contribution de ces activités, la Refactory deviendra également le premier site européen spécialisé dans la mobilité avec un cap de bilan carbone négatif à 2030. La Refactory créera un écosystème ouvert pour innover à chaque étape du cycle de vie du véhicule. À l'horizon 2030, nous visons plus de 3 000 emplois liés à nos activités. Comment? En s'appuyant sur un large réseau de partenaires et à travers 4 pôles d'expertise. 1. Retrofit. Pour prolonger la durée de vie des véhicules et de leurs usages, nous allons rassembler les expertises comme le reconditionnement des véhicules d'occasion ou des flottes, ainsi que le retrofit pour convertir les véhicules vers des énergies moins carbonées. Résultat, des véhicules moins polluants qui roulent plus longtemps. 2. Re-Energy. Nous développerons l'écosystème électrique de nouvelles solutions énergétiques. Réparation des batteries, nouvelles opportunités d'exploitation en seconde vie des batteries, comme le stockage stationnaire des énergies renouvelables. À terme, la Refactory ambitionne également d'être un pionnier de nouvelles sources d'énergie, comme l'hydrogène. 3. Recycle. Le site rassemblera toutes les activités permettant d'optimiser le cycle de vie des matières et des pièces, la collecte, le démantèlement, le réemploi, le remanufacturing et le recyclage. Ces boucles de matières permettront d'approvisionner l'écosystème de la Refactory et de ses partenaires et de continuer à augmenter la part de matériaux recyclés dans les véhicules. 4. Restart. L'innovation et le partage de connaissances sont les moteurs de l'économie circulaire. C'est pourquoi un incubateur de start-up développera des savoir-faire. Un campus universitaire permettra d'accélérer la recherche et la formation à la mobilité de demain. La performance de cet écosystème reposera sur les nombreux atouts du site de Flins, l'efficience des processus industriels et le partage des savoir-faire et des moyens de recherche regroupés en un même lieu. Avec la Refactory, la transformation du groupe Renault est en marche. Le groupe Renault réaffirme son emploi.
So that's quite motivational and interesting and something we need to see a lot more of. What about aerospace? Aerospace like to talk about revenue ton kilometers. So they get revenue by moving mass through a distance. And positive news, CO2 emissions have dropped in the aerospace industry by technology gains, composites, better engines. Trouble is, we're using aerospace more and more and more, and the innovation is not keeping up with this growth. Looking at where aviation CO2 goes, I think it depends upon where your flight starts from, but you can see it's the global north, generally speaking, the rich countries which are emitting CO2. Where can aerospace go to? Relating to composites, keeping them lightweight, hydrogen turbofans, hydrogen turboprops, okay, hydrogen storage, different concepts that Airbus are working on for the future. Okay, so if you're working in aerospace, might well be what you start to work on, these kinds of concepts. Airbus will see 40,000 new aircraft. That's what they're telling their investors from their shareholder presentation. You can see the 1 million flights per year. It dropped in COVID. By 2050, the number of flights will go up, but the emissions will drop by looking at these alternative fuels and propulsion systems, but also by behavioral reductions and how often we fly will need to change as well. But a role there for composites in the structure and in hydrogen storage, okay? So we talked about circularity and we talked about the circular economy. Well, the same professor at Cambridge wrote an article in the Harvard Business Review saying they're great, but why are they so rare? Why don't we see much circularity around us? Why is it so linear? Really interesting. The successful examples tend to be local, with products and services made of limited numbers of components. And it's because of our human supply chains. We like performance via part specialization, okay? And we like economic efficiency by economies of scale. They are the two really big things. We like to specialize to get performance. So Mercedes or BMW like to specialize, and they like to make their vehicles in huge factories. So to make this work, his hypothesis is consumers need to give up performance for environmental sustainability. And businesses need to give up some of the economies of scale and make less sophisticated products. Otherwise, making these circular systems is going to be difficult. We need more standardization designed into the product to make it easier to make products circular. And that's not what we're doing today. Okay, we're carrying on with our linear model, making highly sophisticated parts like a phone. Okay, and we do that mass production, make millions per year. Okay. Apple do have a system where they regrind their phones. They put them into a grinding robot and they separate the materials, but they could do a lot more as well. So that was the kind of barriers. So you can do another opinion for you to give what you think the circular economy is. Just type in your thoughts. It's a lot more, though, than just recycling. As we're going to see in a minute, we're going to look at how this impacts so many more things than just right at the end of life. It's certainly rethinking the way we do things, limiting waste, closing loops, as we heard the definition earlier. Somebody thinks it's regressive rather than progressive. Is that what you intended to say?
Regressive. It's not really negative. It's
Okay.
more about the quality of life.
Okay.
Down.
It's the discussion. You know, it's many different opinions. Somebody may well think it's regressive, so it's okay. You say what you wanted. Socially beneficial. Okay, so that's a bit of feedback. So how can we enable sustainability? So here, I'm going to try and give you some of the vision from this Cambridge course around how we can do this. And when you're in your groups, thinking about your initiatives, yeah, this is what you're going to have to come to. So what are the enablers toward a circular economy? There's three really big enablers. The first one is government and policy. Second is finance and investment, and of course, technology. And we're going to look at government and policy first, then at finance, and thirdly, technology, because technology by itself will not solve this. And the key thing that you need to understand is it's a transdisciplinary approach. Okay, you have an idea for a new technology, you need to work with the finance people, government need to legislate to enable the companies to be freer to operate in that area. So in the future, you know, we can see different labs at EPFL collaborating more and more, different disciplines collaborating more and more. It really needs to be many people around the table with different skill sets. Okay. So we need innovation to address the problem of overconsumption and overproduction. We need innovation in government policies, in business models, circular versus linear, and supply chains. And we need to innovate ourselves how we select and dispose of products. We need to innovate on our own persons. So looking at government policy first, this is what this professor said at Cambridge. His opinion of the role of government policy, and people have different ideas here. He says government should be giving vision, not fixing market failure, but giving inspiration. They should be guiding towards the circular economy. And how do you best guide somebody? Well, you give funding. Professors at EPFL follow the money. Companies follow subsidies. You lubricate with money, people will go that direction. So financial incentives, which are measurable and direct. Governments can take the financial risk, whereas the private sector provides the technology, okay? And that happens a lot in other economies. Look at South Korea, the government invested hugely in technology, okay? Try and achieve growth still, create jobs, you need a stable policy. So this has started, but the funding levels are not yet what McKinsey said, it's 7.5% GDP. It needs to go up. Governments need to invest more. What about finance, the stock market? Well, the good news is that investors are reacting. They are starting to favor sustainable companies, and companies start to get sustainability ratings, okay? They are then more attractive long-term investments. Companies need to remain profitable, for sure. Investing in sustainability is really growing, nearly 30% growth in that. So it's $1 trillion business opportunity. Okay, so it's already around $500 billion invested in what they call impact investments. Okay, so Tesla, go on. Yeah, and greenwashing is really important. It's basically saying I've got a shop window. In my shop window, I have green plants and bamboo, and I'm selling brown items. And then in the back door of my company, basically I flush out all the waste onto the street. So what's in your shop needs to match what's in your window. Otherwise, people can see straight through it. And that really negatively impacts the company's image. Okay, you get yourself into deep water. And one of the modules in this Cambridge course was on communicating your sustainability business model to avoid greenwashing, to be honest with your stakeholders. Okay, so it's really important. But what I'm saying here is that there are investors who are investing in companies who are really doing this. And in a minute, we'll look at an example of a composites company and some of their initiatives. So what you have to look at is what are their initiatives and how much money are they spending on it. Okay, that's what's really important. Okay, so you've got to put your money where your mouth is, okay, not just talk about it. So it's a really good point, and greenwashing is very dangerous when you do it too much. One way of looking at the world is what's called a pestle level analysis, because normally companies like to look at their microeconomics. Okay, profit. What is the bottom line of profit? What do they teach you in business school? Profit. Okay, it's the bottom line. But the bottom line needs to change. Companies have to go from looking at their own internal company's financial situation compared to their competition, mesoeconomics, to the macroeconomic situation, what's going on in around them, political, economic, social, technological, legal, and environmental. And what they call this is the 3 Ps, people, planet, and profit. So yes, you need to make money to stay in business. Yes, you need to look after the planet, but you mustn't forget the people. At the same time, you mustn't forget the planet. So the new bottom line of a company, companies in the future will be assessed on multiple criteria by the stock market, not just their profit. So business models need to evolve to incorporate socially and environmentally sustainable practices. You can transition from your current business model, making a car, to a new business model of making a vehicle. Okay, you can have 2 going at the same time because you can't change your company overnight because it will probably go bankrupt. You have to transition. Okay, people need to redesign their supply chains. Don't take it all offshore in China, for example, because when COVID hits, your supply chain goes crazy and your factories are idle. Okay, you need to have what they call nearshoring and then onshoring. So nearshore could be in Europe, onshore would be in Switzerland. You need a mix. Okay, make it a lattice, yeah, not a chain. Lattice is more robust. We need to bring sustainability into our value propositions, but not greenwashing, as you say, from startups to transformational to big companies. Okay. Ford has split into two companies, one which is internal combustion and one which is electric. So they're keeping their current linear model, which is gasoline, and they're investing $30 to $40 billion into their new electric vehicle lineup. Okay, so companies are really changing. 3 years ago, I would never have believed that Ford would do that. We need to avoid the race to the bottom of the linear economic model. So not making electric vehicles like we make cars today, but changing. Otherwise, we're running to the bottom of the mountain, not trying to climb the peak. If any of you are mountaineers or runners, the Sierre Zinao race, it starts in Sierre and it goes to Zinao. It doesn't go the other way around. Okay, got to run to the top. Sustainable finance. You probably don't know much about finance, or you might know a lot, but people talk about earnings before, so you know what earnings are, money, yes, before you depreciate your assets and you amortize them. Sustainability, according to Professor Safani, can reduce the cost of goods sold by efficiency gains and waste management, making your operations more efficient, selling your waste to somebody else. You can reduce your operating expenses by sharing and by leasing and using services, avoiding redundant assets that are not working for you. And it can increase revenue by making more desirable products. Consumers are becoming sensitive to sustainability and demand is going up. You can map in Migros the amount of vegan food that was sold 2 years ago to today. It's growing. Okay, consumer interest is going up. Migros are making money from it. So he claims that we can increase our gross margin by following sustainability approaches, but some of the feedstocks can be more costly. This is what was his message. And carrying on looking at the sustainability, and this one is basically looking at the earnings retention ratio. It's how much money the company holds back before it pays money to shareholders. So it retains earnings, and that amount needs to go up, and the dividend needs to slightly drop so they can reinvest in new business models and new technologies, and that the stock market will need to adapt to this and actually see it as a positive thing. This company is reinvesting in itself, in its product for the future. It also covers things like where you get your money from, what kind of banks, how you pay your suppliers, how you pay your staff, payment terms, supply conditions and salaries. Okay, this is a people part of it. And companies are again graded on these criteria. Okay, today. Normally companies are look at what's called return on investment. What's your return on the money you've invested in technology? He presented a mathematical equation that we don't have time for, which he calls sustainable return on investment, which looks at profit, yes, but the people and the planet. So it's the social impact of an investment. You build a new factory. What about the environment around it where you're building it? Are you paying people a fair wage? Is people's life quality going up? What about their healthcare? Those are other SDGs. It's not just about making profits. Yet we have to look at this in a wider aspect, and the planet, okay? But don't fall into the trap of just looking at the planet and profits. We need to keep on looking at the people. Really important. So this aims to quantify the financial and non-financial issues in monetary terms. It's trying to monetize the value of people and the planet in an investment. And some companies already use this. I talked about companies being judged on what they do. This is now done by what's called Scope 1, Scope 2, and Scope 3 reporting. And it's here, this is now being proposed by the US Stock Exchange. So this is going to come into law, but companies have to report Scope 1 and Scope 2 emissions, and Scope 3 is voluntary, but it's also coming. Okay, around 90% of the value chain is your upstream and downstream activity from your company. Okay, so if you're Ford, you're making a car, you're buying aluminium and steel and rubber and plastics upstream. And downstream, it's all the garages that service the car and the fuel you buy and the recycling and disposal. So how you make your products affects your suppliers and how you treat them, and then downstream too. This comes into their reporting, so it's how their financial system will compare these companies. This is a diagram you can stare at for quite a long time, which shows the scope 1, scope 2, and scope 3. So scope 1 is what happens inside your company, your facilities, and your vehicles. Scope 2 is the power you purchase. So you could decide to switch to renewable power. Some companies like BMW use 100% renewable energy to manufacture their vehicles. So that's scope 2 indirect they've worked on. Then you need to look at what you're buying, bringing into your company to make your products. So you can start to encourage your suppliers to do certain things. If BMW are really powerful, they can say to their suppliers, we need you to change how you make the products you give us. Because 90% of the impact of BMW is in scope 3, not in scope 1 and scope 2. You understand that? And then scope 3 is after it leaves the factory and it's used, what happens to it is, and you can have an influence on that as well. Okay. So companies are being assessed by these things, and if you go and work in a company, you'll hear a lot about scope 1, scope 2, scope 3. Solvay, a composites company, pretty good sustainability rating. You can see here, scope 1, they have targets. They have targets for scope 3. And if you go on their webpage, they detail which power plants they're switching out of factories, what percentage of their products are in different categories, and they show how they're spending money getting to these objectives. So most big companies now have a sustainability tab on their webpage, and it details their initiatives, okay? And if they're spending money, they're not greenwashing. What are some of the technological enablers to net zero? Looking more at technology. Lots of things we're doing at EPFL, big data and AI, machine learning, the Internet of Things, putting lots of sensors in products so we know when they're wearing out, when they need servicing to avoid throwing them away. The cloud, lots of capturing all this data. A bit about additive manufacturing, and we'll look at that in the third lecture. Look at some parts we can make by additive manufacturing. Of course, novel materials. Satellite technology, we can now see methane leaks and where they're coming from. Blockchain, drones and robotics. A lot of these things can be enablers if they're used in the right way. So we can make a big difference. So before we go on to the third lecture, which is towards sustainable composites, coming back to our materials, a bit of psychology, okay? Who'd expect to hear some psychology in a composites lecture? But you may have heard of Maslow's hierarchy of human needs. Okay, we've all got basic needs. We want to be warm, we want to be fed, we need water and rest. We want to be safe, we want to feel belonged, we want to be in intimate relationships. We want to feel a feeling of prestige and accomplishment, and ultimately we want to self-actualize, we want to achieve what we can really be ourselves. Okay, this all always makes sense and it's very normal. The trouble is there's a conflict between us in the West who want to self-actualize, and maybe we're prepared to pay a bit more for a premium product, against other people who are still trying to feed themselves and their families. And their needs are so pressing that they don't have the headspace to consider their impact on future generations. So like, I need to feed my kid or it's going to die. Okay, what happens afterwards? I can't cope, can't handle. So we get this conflict between different parts of the world. And one way that some people look at this is to use game theory, the prisoner's dilemma. Okay, how many of you have heard of the prisoner's dilemma? Yeah, quite a few of you. Okay, so this can be related to the tension between selfishness and cooperation. So the best way to have the minimum impact is for two people to remain silent. Then they both stay in for 1 year. If B confesses and A confess, they both stay in for 5. If this person remains silent, he stays in for 20. whereas this one gets out. So he's defected. The problem is that people or nations don't cooperate, even though it could be in their combined best interest to do so, because they both take this 1 year hit, but actually they want to get out straight away. Okay. So by prioritizing their personal or national interests, they can create a worse outcome. The thing is, we need to embrace this change together, take the strain, and basically cooperate. It's that mutual cooperation yields a better outcome than mutual defection. Okay. And this applies to all of us. We all make decisions all the time, and we can influence not the whole world, but the things around us. In this course, they introduced a professor in Harvard Business School, and she was the most popular professor in the whole of the business school. And she has two basically hypotheses. There's money lying on the floor to be recovered because we don't do things as efficiently as we could. We need to introduce the true pricing of our waste and emissions. And that doing this needs to become a definer for success. 3 Ps, not just the profit you make in a company. People should be promoted in companies based upon people, planets, and profit. That we need to reinvent capitalism and shift the ethical framework because it's not working. Then what she says, which is the most interesting bit, is that we're emotional people and we have our own core values, okay? And your core values are really important and you need to really respect that you keep them. So we need to be true to ourselves. And this is what will help capitalize change, okay? So if we're going to take risks in how we make decisions, do it for what you really believe in, your core values, and be prepared to stand up and say it. And she gives examples because she also speaks to the boards of companies about how people have started to do this, okay? Stand up for what you believe. So we come to alternative futures, and this is a famous naturalist, David Attenborough, who's been around the world. He lived to be about 90, and he saw countries 30 years ago, 2010, and he's seen the degradation. And he gives this vision for how to change it, which we need to do. We need to try and change the way we're affecting the world around us. Because if we don't, we can end up being in this novel New York 2140, where sea level rise creates huge problems. So I'm really urging you to take this seriously. So together we can make a difference. Each person can influence the world around them and what you do. And we all need to work together. So this is really my kind of summary, is half of the story is a transition to renewable energy. The other half of the story is related to how we make goods and products. And that means we need to redesign our economy to eliminate waste and pollution, recirculate products and materials, and regenerate nature. And the circular economy is going to help us get there.
Climate change is a result of our take, make, waste economy. And until now, we've looked at solving climate change largely by switching to renewable energy. We're replacing fossil fuels with wind and solar power at speed all over the world. But the truth is that the energy transition will only solve half the climate problem. It's like we've been reading only half the book, like we've been watching only half the movie. So what completes the picture? Transforming how industry uses materials, how we manage land. That is, transitioning to a circular economy. It's more than energy. It's about transformation. What does that mean? It means we address things before they become a problem and design out emissions before production even begins. We build an economy that eliminates waste and pollution, keeps products and materials in use, and regenerates natural systems. The circular economy can help address climate change by reducing emissions from industry, land use, and agriculture. So how do we make this transition? by businesses embedding the circular economy in their climate strategies and redesigning products and services, by governments setting enabling policies, putting the necessary infrastructure in place, by investors mobilizing capital towards circular economy solutions.
The circular economy plays a really key role in solving many of the problems around climate change. But what it also does is it builds a more resilient economy.
A complete picture of a thriving zero emissions economy is coming into focus. The mission now is to make it a reality.
Okay, so that was the end of this prefix almost. Okay, the next lecture will take a 5 minutes break, will be towards sustainable composites, which is going to look at the composites industry. Where is it regarding sustainability, its problems, and some trends towards heading in this direction. And after that, I'll just introduce to you the initiatives where in your groups, seeing how relevant do you think it is incorporating sustainability themes into a lecture. Okay, thank you for that. Okay. So when you leave EPFL and you work in either industry or academia, people like to look at all these issues, but what can you do about it? You can have an initiative. So from this course, mine was to give a lecture. Okay, I wrote a pitch, I gave it to Professor Michel, he said, have a go. Okay, so in your group, I want you to think of 3 initiatives. I want them to be smart initiatives. Okay, so they need to be specific, measurable, achievable, sorry, went the wrong way there, relevant, and time-oriented. It really helps to make smart, okay? And you can think about short, medium, and long-term initiatives. In your startup, what could you do straight away? What could you do in the medium? And what could you do in the long term? They could be focused on the operations of the company, how it performs its business. It could be on the product. It could be on its supply chain. It could be related to the industry. So you can think about low cost versus high cost, low benefit, high benefit. Okay, try and think of things which are of high, want to be high benefit, and low cost is the most ideal case, but also up here. So you're going to need to think about these, talk about them. And something that's really important related to climate change is change management, because as a society, we're going to have to change so many things. And you need to go away and think that it's a process and that it involves people. It doesn't happen overnight and it needs lots of effort, okay? There are many different stakeholders involved in initiative. Who do you have to convince to sign off on your initiative? Okay, you basically want to make your stakeholders think that it was their idea, okay? Because if they do, then they're going to go for it. They're going to sign it off. They're going to fund it, okay? So you have to think about the people. And one way you can do that is to think about people who have low interest or high interest, low and high power, and how you're going to engage them closely and influence their activity. If they've got high power and high interest, these are people you need to spend time with, okay? And you can raise awareness with them, you can educate them, you can train teams up, all this kind of stuff. And in real life, you need to make an engagement plan for each stakeholder about how you're going to convince them of what your initiative is. Okay, then you can bring about change. So again, you can think about metrics. How are you going to assess your initiative? Can you do it financially, operationally, or strategically? Just to give you some words to go away with for the future, you might have to convince the CFO of the company on financing. You may have to convince all the operations people in the team who make the people. It may be very strategic, and it's your market share and your company brand which is at stake. Okay, which really changing your business model. So I've made a little spreadsheet for you where you can try and open it up. Basically, you can write in the spreadsheet what your initiative is. It could be, I want to install photovoltaic panels on my factory roof. And then you can start to give some measures and some dates. What are the challenges? What will be needed to resolve the challenge? And how could technology help? And then you can grade it, give it different numbers for it, and just a way of recording your thought process. But what I'd like you to do is to put this in your presentation and your report. 3 initiatives per group. You're free to choose what you like, but just think about it. And you're then the chief sustainability officer in your company, and you've got to maybe convince your group members or whoever, and think about your idea. And be very interesting to see what kind of ideas you come up with for the future. Okay, so that's the end. Thank you for your attention. It was quite long, and I know lots of slides, but hope it's given you some energy and some hope how in your careers you can make a difference in the materials world, in the composites world, and try and fix some of the problems that my generation's left for you, to be honest. So, okay, thank you very much.